Hello, welcome back. We're going to continue our discussion on limits today. Specifically today, we're going to be looking at the horizontal and vertical asymptotes. So let's go ahead and get started. We want to find out, in this case, what's happening as we approach a vertical asymptote. So let's go back to our pre-cal for a moment. If I have some asymptote as some x equals c, I know that the function, as we approach that asymptote, it'll either grow without bounds or it will decrease without bounds. And that's actually how we define what a vertical asymptote is. The definition is the limit as we approach some x value, the y value grows without bounds. In other words, we can say as x gets close to c, from the left to right, these have to be single-sided. The function grows without bounds. We can use this idea to kind of help us determine certain limits of rational functions when it's not indeterminate. But before we can do that, we have to talk about a rule. We have a certain rule for us. What happens as x goes to 0 of 1 over x? Now, again, these do have to be single-sided, so we're going to put a plus or minus on that 0 up there. So we want to think, well, what's happening as x gets really small? I can't really plug in 0 per se, but I can let x get really close. For example, I can let x be 0.1, and that's going to give me 10. But what happens if we let x be 0.01? We're going to get 100. And by now, we should know that, man, this is getting kind of big. The smaller x gets, we get bigger and bigger and bigger. So I know that this is either going to be plus or minus infinity, because as x gets even closer to 0, as x gets close to 0, this gets really big. Y value gets really big. So let's apply the same skill, okay? So we can't plug in 0, but we can get really close to 0. So let's see here. So if we take a look at the first example down here, notice these are going to be single-sided. We'll talk about what happens if they're not single-sided in just a few moments. So if I take a look at number 1 here, we have the limit as x approaches 3 from the left, we're approaching from the left, of this 1 over x plus 3. And we want to find out, well, what is happening to the value of the function? Now, I could graph this, but sometimes graphing takes too long. So what I'm going to do is I'm going to pick a number really close to 3 on the left. So if I think of a number 3, here's the left of 3, here's the right of 3. Now, I know if I plug in, I'm going to get 1 over 0. I know this is going to be infinity. I know that because that's my rule. Up here, 1 over 0 becomes infinity. But what I want to know is that going to be a positive or a negative infinity? Well, to do that, I'm looking at numbers to the left. So pick a number close to 3 on the left of 3. For example, 2. If I let x be 2, notice I'm going to get 1 over 2 minus 3. Well, what's 2 minus 3? A positive 1. So the top is going to become positive. 1's always positive. The bottom, 2 minus 3, is negative. So I have a positive over a negative. Well, what's a positive divided by negative? But a negative. So we get a negative infinity right there. So even though it's like 1 over 0, the 0 is kind of negative. We're approaching 0 from the negative side, and that's what we're saying right here. As x gets really close to 3, the bottom is approaching 0, but from the left side, from the negative side of it. So let's try number 2, same way. Ready? If we were to try to plug in 4, we would get 1 over 0 squared. Now, my rule is that this is either plus or minus infinity. So all I'm going to do is I'm going to pick a number close to 4, but this time on the right. So let x be 5. And if we do that, we would get 1 over 5 minus 4. 1 squared is 1. Notice the top is positive, the bottom is positive. So this is going to become positive infinity. Very easy to do. And we can verify that if we were to graph it. Here's 4. We know what 1 over x minus 4 squared looks like. There it is. As we approach 4 from the right, it's approaching positive infinity. Now, the goal is to do this in your head. And that's what I want you guys to be able to do. Number 3, notice we got -1, but every time we plug a 3, we're going to get 0. Again, we're coming in from the left, so I'll pick x equals 2 again. So if I pick x minus 2, 2 minus 3 is -1. So the top is positive, and now the bottom is negative. Sorry, the top is negative, and the bottom is negative. 1 over 0 is infinity, and because they're both negative, we get positive infinity right there. Very easy to do. Ready? Let's try the next one. If I plug this in, I get a positive 2, the bottom. If I do get 0 if I plug in, we're approaching from the right, so pick a number close to -3 from the right. So if here's -3, right? There's -4, -2. So I'll pick -2. So I would get 2 over -2 plus 3. I get 2 over -1. The top is positive, the bottom is negative. I know this is going to be infinity, but it's going to become a negative infinity because a positive and a negative make a negative right there. And again, I can verify this if I wanted to. You don't have to. My asymptote is at -3. I know what this function looks like. Hello. Right now, oh no, did I mess up here? Let's take a look here. X0 positive 2/3. We get something like this. And how come I got the wrong sign right there? Let me just double check. From the right, -2 plus 3. I was doing really good. All right, but we're going to move on to the next one. We'll talk about that one later on in class. I'll probably hear comments on that one. All right, so let's try the next one here. We pick a -4 here. If we throw in a -4, once again, we're going to negative over 0. Now notice we're squaring the bottom. So no matter what we do to the bottom's always going to be what? Positive. That's an easy way to do it. It doesn't matter what I plug in. I could pick something, but it's going to become 0 there. So I'm either going to get plus or minus infinity. Now you want to be really careful with this one. Notice in this one, there is no right or left. There is no right and there is no left side. So if I were to graph it, now we're going to talk about this a lot. At -4, we do have a vertical asymptote, and we know it's opening down on both sides. Now, according to our new rule, we should get negative infinity. And this is okay to write. The AP will be okay with that. But when we think of a limit, for a limit to exist, both sides must approach the same number. Both sides have to approach the same number. Now, we've talked about this before in class. If this one is approaching negative infinity and this one's approaching negative infinity, so you're right, they're both approaching this negative infinity. But one thing we mentioned in class and in the previous video is that infinities don't equal to each other. So even though these are both approaching infinity, negative infinity right here, we want to be really careful. A better way to explain this one is that it's going to be a D&E. And the reason we say that is because we're not approaching the same number. Because infinity doesn't equal infinity necessarily in mathematics. We've got to be really careful dealing with infinities. So D&E is going to be the better approach for it. And we're going to say that this is because x equals -4 is asymptotic. Now, be careful. This is only for non-single-sided. Because I don't have a left or right, I have to look at both sides in this case. All right, number 5. Let's take a look at number 5. I can split this up. One thing we can do with limits, we can always split them up. This becomes 5 minus x minus the limit as x approaches -5 of 1 over 5. Let's make this a plus x. Plus x. There we go. That has become a plus x right there. Now, if I plug in the -5 here, we would get 5 minus a -5. Minus, but let's do it in here. Here, I'm going to get 1 on top, but I'm going to get 0 on bottom. So remember, so this becomes 10 minus something with an infinity on it. So we're approaching from the right side, So I pick a number close to -5 on the right. So if I need to, here's -5, -4. So I'll pick -4. 5 minus 4 becomes 1. So the bottom becomes positive. So I got a positive 1 on top and a positive 0 on bottom. And then we get positive infinity. So what's 10 minus infinity? Oh, that's just negative infinity right there. All right, hope you enjoyed this video. I'm going to go back and search for number 4. I'll probably put the fix in another video. I hope you enjoyed it. Bye-bye.